In progress.
Hey there, everybody. Welcome back. We are going to start chapter 4. We're again in johnblakely.com's textbook. There's our website right there. And we're doing chapter 4, which you can see is on factoring. So chapter 4 is on factoring polynomials. It's on factoring, period. In 4.1, we're going to do common factors. And this is all dependent on that distributive property we did before. Recall if we had A times B plus C, it became A times B plus A times C. Well, we were going that direction, but for factoring, we go the other direction. Go backwards. We're going to start here and we're going to go here. All right. So the idea is to pull out the largest factor that is common to all the terms. Common or shared by all the terms. All terms. This is called the GCF, greatest common factor. Okay. And that table we did for the LCD, we can do something here. What we need to make sure we pull out, though, is the largest number in common amongst all the coefficients. So the largest number shared by all coefficients as a factor, I should say. That reads a little bit better. And then what we're going to do for the second part, for each variable, factor out that variable to the lowest power present. Okay. All right, let's take a look at some examples. Let's go with 42x squared minus 14x plus 49x to the fourth. Okay, so I'm going to do the numbers separately from the variables. So I have a 42, a 14, and a 49. 42 is 7 times 6, and 6 is 2 times 3. So 7 times 2 times 3. 14 is 7 times 2. And 49 is 7 times 7. So I'm making a table like I did for LCD, but now this difference was for LCD, we had one from each column. For the greatest common factor, we are only going to use completely filled columns. So the greatest common factor here is the 7. What is left over what's left is the coefficients after we factor. So if I pull out a 7, I am going to have 2 times 3, which is 6. And this is a minus 2, and then a 7. I wouldn't normally do it like this, but I'm trying to show you each thing term by term. Then I'm going with the variables, x squared, x, and x to the 4th. The lowest power present is the x to the 1st power. This one has an extra x, and this one has an extra x cubed. So my GCF here is, again, the completely filled columns, x. And what I have left over is the things that remain. So the x went with the 42, the x cubed was with the 49, and just keep them in the same order. Or you can do one table where they're all together. Did that work? Let's check. We can always check if our factoring is correct by distributing again. 7x times 6x is 42x squared. 7x times -2 is 14x. And 7x times 7x cubed is 49x to the 4th. And that was what we started with. So that is the correct factoring. I think the hardest part of this is finding the coefficient that factors out that's the smallest, because people don't always take the time to do a full factorization. Okay? So let's take a look at a couple more. I recommend you give it a try by pausing the video. Let's do 32x cubed y minus 4x squared y squared plus 20xy cubed. Keeps blowing. I got a fan on in here because it's a little warm in the house. All right, I'll assume you pause and give it a try. I'm going to make one big table rather than doing them individually. Four is 2 times 2. That one's pretty easy. 20 is 2 times 2 times 5, 4 times 5. 32 is 4 times 8. This was the 4. And since this is the last one I'm doing, rather than doing a full factorization, I'm just going to put the 8. If I had more things to factor, I would write out 2 times 2 times 2. Now I'm going to go with the x's. I look for the lowest x present. There is a single x, and they all have that. This one needs another x squared, and this one needs another x. And finally, the lowest y present is here, y to the 1st power. So they all have a y. This one needs another y, and this one needs another y squared. So my greatest common factor is this column, this column, this column, this column. 2 times 2 times x times y, 4xy. What do I have left over? On the first row, I have 8x squared. Then I have a minus, and I have xy left. And on the final one, I have 5y squared, which is a plus. What we're really doing, because we showed division with monomials the other video, When we find the 4xy, what I'm doing is really doing this. If I keep the original like that, if this helps, this is an easy way to factor. If you're good with that, ignore what I'm doing now. What I'm doing here is now I'm multiplying it by my greatest common factor over itself. This is just 1. I'm multiplying by 1, which doesn't change the value. But then I'm going to move this underneath each of these, just the denominator. And I'm left with 4xy left on the outside. I've got 32x cubed y over 4xy here, minus 4x squared y squared over 4xy here, and plus 20xy cubed over 4xy here. And that's how we end up with the 4xy times 8x squared minus xy plus 5y squared. The table just shortcuts that and helps identify the factors a little bit. Okay? If you don't like the table, you don't have to do the table. But it's a working thing. Works for this and the lowest common denominator. All right, let's take a look at a couple more. We have C. I'm going to work on 15L squared minus 21LW squared plus 36LH or HL. I'll put 2 of them up right now for you to do. Then we'll factor them together after you give them a try. 21y squared minus 14y cubed plus 7y. I'll assume you gave it a try. Let's get started. Fifteen is 3 times 5. 21 is 3 times 7. Looks like the only thing I could possibly have in common here is a 3. And 36 is 3 times 12. Then I look for L's. These each have an L. And the top one has another L. This has a W squared and this has an H. And the only things I see in common are the 3 and the L. What I have left over is 5L minus 7W squared plus 12H. So the GCF was 3 and L. Something to know, if a row has nothing left, use a 1 in the parentheses. And I think that shows up in the next one. Here I have 21y squared, 14y cubed, 7y. They each have a 7 in them. That has a 3 and this has a 2. They each have a y. This has one more y and this has a y squared. GCF is 7y. This row has nothing left in it, so I'm going to use a 1. I pull out my 7y. What I have left is 3y minus 2y squared plus a 1. That's that answer. This was this answer up here. We got one more thing we're gonna show how to do in the common factors video. And this is when we have a couple, like two binomials. Check this out. We're on E now. I've got 4z times 3z plus 2 plus 5 times 3z plus 2. This is just one term, and this is just one term. I can see that the 4, there's no 4 over here, and the 5, there's no z. But they both have 3z plus 2 in common. So rather than multiplying them out and then factoring again, what I can do is factor out this 3z plus 2. And what I'm left over with is 4z plus 5. Does that work correctly? Just distribute partially. 4z times that. And then plus 5 times 3z plus 2. So yeah, it does get it back. Why don't you guys give it a try real quick? All right, Professor Hefe got sneaky here. If I do this out on a table, they both have a 4 in common as well. So my GCF is 4 times 3a minus 2b. And I'm left with a 3x and a 2y. 3x, this was a plus, 2y. All right, that'll be it for 4.1. Peace.